In our previous video, we started with a polynomial function and we split that polynomial function into a linear and quadratic piece. We called this an irreducible quadratic because we could not factor it. Now in this problem, we're going to change that irreducible quadratic to linear factors with complex coefficients. If a quadratic expression is not factorable, we're going to have to use what's called the quadratic formula to change it to a linear factor. The quadratic formula says that x is equal to negative b plus or minus root b squared minus 4ac, all divided by 2a. To find a, b, and c, we look to our quadratic piece. Our a is positive 2, our b is negative 3, and our c is positive 6. We'll place each of those numbers into the quadratic formula, starting with negative b. If we have negative b, we'll take negative of negative 3 and get positive 3. We'll say plus or minus negative 3 squared. Negative 3 squared would give us 9. Minus 4 times a, which is 2, times c, which is 6. This will all be divided by 2 times a. Our a was 2, so 2 times 2 would give us 4. Next, we're going to simplify this part of the root, this negative 4 times 2 times 6. Negative 4 times 2 would give us negative 8, and negative 8 times 6 would give us negative 48. So now we'll have 3 plus or minus root 9 minus 48, all divided by 4. If we take 9 minus that 48, we'll end up with negative 39. We'll simplify this expression on the next slide. We're going to begin by simplifying this square root. Now, since we have a negative inside of that square root, we can split this root negative 39 into root negative 1 root 39. The reason we can do this is because root negative 1 is actually I. Anytime you have a root negative 1 anywhere, you can say I in place of that. And if you have a negative number in a root, you can split the negative 1 off and write I. Once you've done so, we can try to think of ways we can simplify square root of 39. The way to do so is to try dividing by perfect squares. However, if you go to your calculator and take 39 divided by 4, you will not get a whole number. You'll end up with 9.75. If you try the same thing with 9, you'll similarly find that it will not give you a whole number. If you do the same with 16, once again you'll find it will not give you a whole number. Therefore, we have no choice but to leave that root 39 as itself, root 39. So in place of the root negative 39, the only thing we can do is write I root 39. To simplify a little further, we can split this big fraction into 2 smaller fractions. We're going to split it at the plus or minus symbol. So rather than writing 3 plus or minus I root 39 all over 4, we can split the fraction at that symbol, and we can write x is equal to 3/4 plus or minus I root 39 over 4. However, this is actually 2 solutions. To write our solutions for the quadratic, we'll say our first solution is x equals 3/4 minus I root 39 over 4. Our second solution will be 3/4 plus I root 39 over 4. And our linear solution will have us setting x minus 2 equal to 0. And then when we solve for x, we'll add 2 to both sides. And then we'll end up with x equals 2 for our final solution. These solutions are also called zeros. This x equals 2 we call a real zero, And then our other solutions, the 3/4 plus or minus I root 39 over 4, we'll call complex zeros. Now that we have our real and complex zeros, we'll write our linear factors on the next slide. To recap what we've done, we found one real and two complex zeros. Our real zero came from our linear factor, x minus 2, and that gave us x equals 2 as our real zero. Our complex zeros came from our quadratic factor. We used the quadratic formula on that to get these complex zeros. Now, to write our linear factors with complex coefficients, all we'll need to do is move absolutely everything onto the left side for each of these three zeros we found, and then get 0 on the right. If we did this to our x equals 2, we'll subtract 2 from both sides and end up with x minus 2 for our first factor. If we do the same thing to our first complex factor, we will be subtracting 3/4 from both sides, and then also adding I root 39 over 4. Don't worry about what exactly that is. We can just keep that as an irrational number over 4. So in our first complex factor, we'll end up with x minus 3/4 plus I root 39 over 4. Finally, for our third zero, we'll do the same and subtract 3/4 from both sides and subtract I root 39 over 4 on both sides. When we do the subtraction on the left, we'll still have x. We'll now have minus 3/4 and now minus I root 39 over 4. What we have now with these three parentheses is a set of linear factors with complex coefficients. So just like we can subtract 2 from both sides for our real zero, we can subtract a set of fractions and complex terms the same way in order to get our factors. Thank you for watching. We'll see you again soon.